every Lockheed Martin aircraft ever made. One of these was built to spy on a nuclear superpower at the edge of space, and the CIA had to create fake shell companies just to buy the raw titanium from the very enemy they were targeting. There were 10 legendary aircraft lines that defined this company's entire history. This is every single one. In 1941, the P-38 Lightning rolled out of Burbank as a twin-engine heavy fighter built to shatter altitude and speed records during the Second World War. German pilots were so terrified of its twin-boom silhouette that they nicknamed it the Fork-Tailed Devil, and it was the exact airframe used to fly the long-range mission that intercepted and shot down Admiral Isoroku Yamamoto over the Pacific. Powered by two Allison V1710 turbocharged piston engines, it could hit 414 miles per hour at 25,000 feet while carrying an offensive armament concentrated entirely in the nose rather than the wings. In my opinion, the P-38 is the most aesthetically radical fighter of the Second World War, proving that unorthodox geometry could outperform traditional single-engine dogfighters when brute force and high-altitude interception were what mattered most. But while the P-38 conquered piston-engine warfare, the dawn of the jet age demanded something much faster, leading directly to a top-secret project built in just 143 days. In 1944, the P-80 Shooting Star entered service as America's very first operational jet fighter, designed to counter the sudden arrival of German turbojets over Europe. Designed by legendary engineer Clarence Kelly Johnson in a rented circus tent that smelled so bad from a nearby plastics factory that engineers jokingly called it the Skunk Works, the P-80 went from a formal contract signature to its first test flight in less than 5 months. Driven by a single Allison J-33 centrifugal flow turbojet engine producing 4,000 pounds of thrust, it achieved a top-level speed of 594 miles per hour at sea level. If you ask me, the Shooting Star isn't remembered for its combat record as much as it should be, because it is the absolute mechanical blueprint for every single modern American jet fighter that followed. Yet, as jet propulsion matured, engineers realized that flying level wasn't enough, and by the mid-1950s, they designed a fighter that didn't just push the envelope. It tried to pierce the stratosphere. In 1954, the F-104 Starfighter took to the skies as a high-altitude, supersonic interceptor built for the United States Air Force and NATO allies. Its trapezoidal wings were so razor-thin, just 3.4 inches thick at the root, that ground crews had to install protective felt covers along the leading edges, just to keep maintenance technicians from accidentally slicing their hands open on the tarmac. With a General Electric J-79 afterburning turbojet generating over 15,000 pounds of thrust, it became the first operational aircraft capable of sustained Mach 2 flight, reaching a maximum speed of 1,528 miles per hour. The Starfighter was a magnificent engineering experiment that was frankly terrible as a tactical dogfighter, earning its tragic nickname, the Widowmaker, because it sacrificed every drop of aerodynamic forgiveness for pure, unadulterated speed. And speaking of unadulterated speed, if you are enjoying this breakdown of aviation history so far, the next complete manufacturer lineup is already scripted and ready for production, so hit that subscribe button right now so you don't miss it. Now, while the Starfighter was catching fire in the press, Skunk Works was quietly building a machine designed never to be seen at all. In 1955, the U-2 Dragon Lady was deployed as an ultra-high-altitude strategic reconnaissance aircraft engineered to peer straight down into Soviet military installations. Because it flies like a motorized glider in a tiny atmospheric envelope known to pilots as the coffin corner, where stall speed and critical Mach speed are separated by just 5 knots, pilots have to be talked down to the runway by chase cars driving at 100 miles per hour on the tarmac below. Operating above 70,000 feet, its 103-foot wingspan allows it to loiter over hostile territory for more than 12 hours at a stretch, while photographing targets with camera lenses that can resolve a newspaper headline from the stratosphere. To me, the fact that a Cold War spy plane from 1955 is still actively flying reconnaissance missions today proves that raw mechanical simplicity will always outlive overcomplicated digital alternatives. But when Soviet surface-to-air missiles finally caught up to the Dragon Lady's altitude, the engineers at Burbank realized that height alone was no longer a shield, which brings us to the most impossible machine ever built. In 1964, the SR-71 Blackbird entered service as a strategic Mach 3+ reconnaissance aircraft built to outrun any air defense system on Earth. Over its entire 34-year operational career, more than 4,000 surface-to-air missiles were fired at the Blackbird, and not a single one ever hit its mark because the standard pilot evasive maneuver was simply to push the throttle forward and outrun the missile. Powered by two Pratt & Whitney J58 continuous bleed afterburning turbojets, it cruised at Mach 3.2, over 2,200 miles per hour, at altitudes exceeding 85,000 feet, while its titanium skin expanded by several inches from sheer kinetic friction. The Blackbird is unquestionably the pinnacle of 20th-century aviation design, an untouchable masterpiece that looks more futuristic today than almost anything sitting on a modern runway. Of course, not every mission calls for outrunning missiles at the edge of space. Sometimes an Air Force just needs to move an entire army across the globe without landing on a paved runway. Also born in 1954, the C-130 Hercules became the backbone of tactical airlift operations around the world, proving that versatility is just as lethal as speed. In 1963, a Marine Corps KC-130F made history by landing on and taking off from the aircraft carrier USS Forrestal without arresting gear or catapults, making it the largest and heaviest aircraft ever to operate from a naval deck. Driven by four Allison T-56 turboprop engines turning four-bladed propellers, it can carry 45,000 pounds of cargo, armored vehicles or paratroopers, and land on rough dirt strips in under 3,000 feet of runway. Even if it isn't supersonic or stealthy, the Hercules is pound for pound the most valuable military aircraft ever manufactured, and the aviation world would literally grind to a halt without it. Now ask yourself a question. What happens when radar technology evolves so rapidly that neither speed nor altitude can keep a plane alive? In 1981, the F-1117 Nighthawk secretly took flight as the world's first operational stealth attack aircraft, built to slip through dense radar networks completely undetected. Because 1970s computers weren't powerful enough to calculate radar reflections over curved surfaces, the Nighthawk was designed entirely with flat, faceted panels, making it so aerodynamically unstable that pilots jokingly called it the hopeless diamond. Equipped with two General Electric F404 non-afterburning turbofans buried inside specialized radar-absorbent exhausts, its radar cross-section is smaller than a metal ball bearing, though its top speed is limited to just 684 miles per hour. The Nighthawk is a brilliantly flawed transition piece in aviation history. It sacrificed speed, maneuverability, and payload entirely just to prove that invisibility was mathematically possible. Once that mathematical invisibility was mastered, the challenge was no longer just hiding from radar, but combining stealth with the aerodynamic agility of a world-class air superiority fighter. In 1997, the F-22 Raptor arrived as the first fifth-generation tactical air superiority fighter, engineered to clear hostile skies before the enemy even knows an engagement has started. Its thrust vectoring nozzles tilt 20 degrees up or down, allowing it to perform post-stall aerial maneuvers that literally defy conventional aerodynamics, and federal law explicitly bans its export to any foreign nation, even America's closest military allies. Powered by twin Pratt & Whitney F119 afterburning turbofans, it can supercruise at Mach 1.8 without using fuel-hungry afterburners, while reaching a maximum speed of Mach 2.25. The Raptor remains the undisputed king of air-to-air combat, and the decision to shut down its production line at just 195 airframes stands as one of the most short-sighted strategic blunders in modern military history. Which brings us to the question I want you to answer today. Looking at where stealth started with the faceted Nighthawk versus where it landed with the Raptor, Which design philosophy would you trust with your life at 30,000 feet? Drop your answer in the comments below right now. But while the Raptor was built to dominate the sky alone, its younger sibling was engineered to connect an entire battlefield. In 2006, the F-35 Lightning II took flight as a multi-role fifth-generation strike fighter built for the United States and global partners across 3 distinct variants. The pilot doesn't use a traditional heads-up display on the dashboard. Instead, a $400,000 helmet projects infrared imagery directly onto their visor, allowing them to look straight down through the floor of the cockpit, as if the plane were transparent. With a single Pratt & Whitney F-135 engine producing 43,000 pounds of thrust, the most powerful fighter engine ever built, it carries an internal weapon payload of 5,700 pounds at speeds up to Mach 1.6. Despite over a decade of relentless media criticism regarding its cost overruns, the F-35 is actually the most lethal electronic warfare platform in existence, operating less like a traditional fighter jet and more like a flying supercomputer that commands the airspace around it. And that brings us to our final aircraft, the experimental machine that takes us all the way back to the secrecy and ambition of our opening story. Recently unveiled in 2024, the X-59 QueSST represents the company's latest experimental supersonic research aircraft, built for NASA by the Skunk Works team in Palmdale. To eliminate the deafening sonic boom that banned commercial supersonic flight over land for decades, engineers removed the forward windscreen entirely, forcing the pilot to navigate using a 4K external visual display system fed by high-resolution nose cameras. Powered by a General Electric F414 afterburning turbofan, it is engineered to cruise at Mach 1.4 at 55,000 feet, while generating an acoustic thump on the ground no louder than a car door slamming down the street. I believe the X-59 is the most important civil aviation experiment of our lifetime, because if Skunk Works can successfully silence the sonic boom, they won't just change military reconnaissance. They will permanently rewrite how everyday humans travel across the globe. And that obsession with doing the impossible is exactly why the aircraft I opened with, the Mach 3 SR-71 Blackbird, required the CIA to build fake companies just to source Soviet titanium. If you want to see which manufacturer we uncover next, the script is already in production, so hit subscribe right now, and I'll see you in the next hangar.